All right, so these are going to be our notes on direct variation. So we're going to go and jump down to number 2. It says the equation of a direct variation is written as, okay, it is going to be y equals k times x. So my equation for direct variation is going to be y equals k times x, where k represents our constant of proportionality. Okay, so y is going to be equal to kx, where k is our constant of proportionality. Okay, what we've been referring to that as in our previous lessons is slope. Okay, slope is a constant. Okay, and k in this case is a constant of proportionality. All right, we're going to go and jump back up to the top. It says a direct variation is a special relationship in which there is a constant. Okay, you'll see here in just a second that's going to be a ratio of, and we're going to go ahead and figure that out real quick. So I know my equation is y equals k times x. Okay, we've got to solve for our constant, which is in this case k. So, and if I have k times x, I've got to do the opposite, which would be divide by x in order to get k by itself. So, k is equal to y divided by x. So, if k is equal to y divided by x, I know that k is going to be a constant ratio of y divided by x. All right. So now let's go and talk about what does this mean b always equals. Well, what it's referring to here is our slope-intercept, all right, equation, which is y equals mx plus b. All right, if I compare these two equations, I can see that they have some very similar things. Okay, but that being said, they're not the exact same. So if y equals a constant, which we know k is our constant of proportionality, and we know that m is slope, times k, and then over here I have plus b, and over here I have plus 0. Okay, I could write plus 0 here and it wouldn't change it. So what does this mean b always equals? I know that it's going to be 0, because if I wrote plus 0 here to represent that plus b, it wouldn't change this equation at all. Okay, so now let's talk about what it being 0 even means. So I know that when I'm talking about slope-intercept form, I have slope right here, and this is going to be my y-intercept, okay? So if 0 is going to represent my y-intercept for this equation, okay, let's go ahead and figure out what my x-intercept would be. So I know that if I'm solving for x, then I'm going to plug 0 in for y. So I get 0 equals k times x, all right, if I'm looking for my x-intercept. All right. So in order to get x by itself, I would divide by k on each side. Okay, divide by k on each side. So x is going to be equal to 0 divided by k. Well, 0 divided by anything is automatically going to give me 0. Okay, so that tells me that my x-intercept is going to be 0 as well. So if my y-intercept is 0 and my x-intercept is 0, that means that for direct variation, means that the equations for direct variation must go through the origin. Because I know the origin is 0, 0. Okay, so it means that the equations for direct variation must go through, that should say go through the origin. Oof, I'm struggling a little bit today. Must go through the origin. Sorry, I messed that up a little bit. Must go through the origin. I apologize. All right, so there are our notes for direct variation. Now we're going to go ahead and do some practice problems. So it says identify the constant and equation of the ordered pairs below. Okay, once again, ordered pairs are just points. They're the same thing as coordinates, all that good stuff. Okay, so I know in order to find the constant, I'm going to have a ratio of y divided by x. So I have k equals y divided by x. All right, I label my coordinates here. So I have x and y. So I plug those in. On top, I have y, which in this case is going to be represented by 6. Over here, x is represented by 12. Okay, so I've plugged in what it's given me. Now, I'm going to use my calculator, okay, and I'm going to figure out how to simplify this. So I have 6 divided by 12, okay, it gives me 0.5. All right, that's not the fraction format that we've been using for slope. So what we can do is we hit math. It's already on fraction, so I just hit enter, and then I hit enter again in order to get what that simplifies down to be. So I now know that 6/12 simplifies down to 1/2. So 6 over 12 is 1/2. You could also do this by dividing by 6 on each, the top and the bottom there, okay? So I'm going to go ahead and check the rest of these. If I put 4 divided by 8, okay, my y divided by my x, I would also get 1/2. If I did 7 divided by 14, I would also get 1/2. If I did -3 divided by -6, I would also get 1/2. Okay, I could plug all of those into my calculator and double check those, all right? So now that I know that all of these are 1/2, all right, my constant, which is k, is going to be equal to 1/2. All right, we just found that out over here. So now when we write our equation, I know my equation is going to be y equals kx. All right, y equals kx. So I have y equals 1/2, because we just said that's what k represents, and then I have x here. So y equals 1/2 x. All right, that's the equation we get. All right, now let's keep going through this. So number 4 says, determine which equations below represent a direct variation. If they do, identify the constant of variation. Okay, so if I look at these examples here, okay, I have the format y equals kx. So I know that yes, because there's nothing written here, there's no b, yes, this is a direct variation problem, okay, and it says if they do, identify the constant. Well, I know the constant is what's right in front of k, so my constant here is going to be equal to 4. Okay, so yes, this is a direct variation problem, and k is equal to 4. All right, now let's go ahead and look at b. I have y equals k, but I am missing the x there. Okay, I do not have the x. So no, this is not a direct variation problem. Okay, we've got to match this format here. So I look at the next step. Okay, I know when I have direct variation, I've got to have y all by itself, which I don't have right now. So I've got to solve for y. All right, we've already been doing this in class, so that's a bonus for us. All right, so I have this plus x attached to my y, so I subtract x on each side. Those will cancel out. So I get -3y equals -x. Okay, my next step, because I have -3 times y, is going to be to divide by -3. Those cancel out. So I get y is equal to, okay, I could either write this as x over 3, or I know it's the same as 1/3 x. Okay, I could have that x on top, but instead we want to write it in the same format. Okay, that negative over that negative would cancel there, so I would just be left with positive 1/3 x. So now we have it solved for y. So now it looks similar to this setup. So now let's just check it. So I have y equals k times x. Okay, so I can see, yes, this is a direct variation problem, and my constant here is going to be 1/3. Okay, so K is going to be equal to 1/3. All right, so you have two examples of those being direct variation and one where it is not. Okay, so moving on along, two more problems to go on this sheet of paper. So number 5, it says, what point does a direct variation always pass through? Okay, it has always got to pass through the origin. Okay, that was that note, the notes I kind of messed up the writing up here for. All right, it must always pass through the origin. All right, which is 0.00. On number 6, it says, if the ordered pairs below represent a direct variation, find the missing value. All right, so for direct variation, I know I have x and y, x and y. Okay, I can set these up proportionally. So I can actually set up a proportion. So I know that it is y over x, so I'm going to get 16 over -4, okay, because I have y divided by x, same setup we've been doing, is going to be equal to, all right, I'm going to set up my proportion. I have my y, which is -52 here, divided by x, okay. So now I have a proportion set up, okay. I'm going to cross multiply, or do the butterfly method, cross multiply and divide. So I get 16 times x equals, I have -4 times -52. All right. When I plug this into a calculator, all right, I would get, I know on this side it's still just going to be 16x equals, I have -4 times -52. Ooh, that's very hard to see, sorry. So I have -4 times -52, which would give me 208. So I get equals 208. I know I'm solving for x, so I have 16 times x, so I divide each side by 16. That cancels, so x is now going to be equal to 208 divided by 16, which gives me 13 there. So my missing value is going to be 13. So x is going to equal 13. All right. So that is that whole entire first page. I want to show just a couple of examples on the next page. In your notes. All right. So looking at the next page, we're going to go and look at number 2. Okay, it's similar to what we've already done, but since it is a little bit different, I just want to go ahead and go over it. So it says you're looking for the constant and the equation, all right? So I know that in order to find the constant, that is still going to be k equals y divided by x. So that's what I've got to figure out here. So I've got k equals, all right, if I use this first set a point here, the first coordinate ordered pair, I get -12 divided by -6. Okay, once again, we can plug that into our calculator, all right? I get -12 divided by -6, okay, which gives me 2. All right, so it gives me 2 there. All right, if I went through the rest of these, okay, -2 divided by -1 would give me 2. 4 divided by 2 would give me 2, and 8 divided by 4 would also give me 2. So I can check all of those. Once I know that they're all good to go, I can write my constant, which is going to be 2. All right. Since it tells me that this is a direct variation problem and it's a direct variation equation, all right, I just go ahead and write in the constant I solve for. So my equation, as we said on the previous page, is y equals kx. So all I have to write is y equals 2x. Just plugging in that constant there. Okay, plugging in that constant there. All right, you will need to try 1, 3, and 4. Okay, I'm going to go ahead and skip down to the bottom. All right, skip down to the bottom here. So we're going to go ahead and look at number 6, okay? I know that, once again, my equation is y equals k times x, all right? So if I look at number 6, it says y equals negative 2x plus 1, okay? I have y equals a constant times x, but here I have that plus 1. I know that my equation has plus 0 because it always goes through my origin. So these are not the same. So no, this is not a direct variation problem, okay? Because I'm not supposed to have a y-intercept there. That plus 1 represents the y-intercept. Okay, what's nice about this is given an equation, I can also go and try this in my calculator. So we go to y equals, okay, I hit y equals. All right, I plug in negative 2x plus 1, okay, the equation given to me. I go to graph, and I look at my equation. I can zoom in if I need to. Oops, wrong one. I hit zoom in. Okay, does my line go through the origin? Okay, my cursor's on 0, 0 where it's blinking. Okay, no, it does not go through the origin. All right, I can see it misses that. So once again, I can use my calculator to check this. No, it is not a direct variation problem. Okay, so now let's go ahead and try number 7. All right, I know that I've got to have y all by itself. So here I have to solve for y. Okay, so if I'm going to solve for y, I have negative 2 times y. I'm going to do the opposite of that there, which is going to be to divide by negative 2. So y is going to equal, I have negative 6 divided by negative 2, which would give me 3x. Okay, so if I compare my formats, I have y equals a constant times k plus nothing. Okay, so yes, this is a direct variation problem. Okay, and it says identify the constant. I know that my constant here is going to be the 3 that we solved for. All right. Got 2 more problems we're going to work through and we'll be done. So you'll do number 5 and number 8. Okay, on number 8, I see that I have to solve for y. That's a hint on that one. If you're going to go ahead and solve that now. All right, this bottom part says identify the graphs below that represent a direct variation. If yes, identify the constant of variation. Okay, so I'm going to go and look at number 9. All right, I've got to check 2 things. First of all, is it a straight line? Do I have a linear line? Okay, yes, it is a linear line. I see that that is a straight line. Second thing I have to check is does it go through the origin? Okay, I look here. Yes, it does go through the origin, and it is a straight line. So yes, this is a direct variation problem. Okay, so now it says I have to find my constant. All right, I know that in order to find my constant, it's similar to slope. So I'm going to use my knowledge of slope to help me out with this. So I'm going to select 2 points that I see that it goes through. Okay. Oh, that looks so goofy. All right, so I've got these 2 points here. It's going down, so I connect my triangle at the bottom. And then I go through and figure out my slope. It goes down 1, 2, 3, 4. Okay, so I have negative 4, and it goes over 1, 2, 3, 4, 5. So my slope here, or my constant, is going to be my rise over my run. Okay, so my rise, okay, I'm going down negative 4, and my run is 5. Okay, so my constant there is going to be negative 4/5. All right, now let's go ahead and look at number 10, and we will be done with these notes, and you'll try number 11 on your own. Number 10, okay, first thing I've got to check, is it a linear line? Is it a direct variation? Yes, okay, it is a linear line. Now I've got to check, does it go through the origin? Okay, this line will never go through my origin or point 0, 0. So no, this is not a direct variation problem because It does not go through the origin, which I know is 0.00. All right, so you will try number 11. Oops, sorry, let me scoot up a little bit so you can see the rest of that. So you'll try number 11, number 5, number 8, and then 1, 3, and 4 on this sheet of paper. Okay, I already did the whole first sheet for you, so that hopefully was helpful for you. All right, we're going to go ahead and just review over this real quick. So I know that direct variation, the equation is y equals kx, okay, where my constant, which is a constant of proportionality, which is also known as slope, is a ratio of y divided by x. Okay, the other thing I have to remember is that my b is always equal to 0, okay, which means that what point does a direct variation always have to pass through is going to be 0, 0. It's got to pass through the origin, all right? So that is our direct variation notes. I know that was a lot, but you should now be completely set up for direct variation.